My name is Himagi. Today I will be walking you through a process of developing a predictive model that automates the task of forecasting net hourly electrical energy output for a power plant. So, getting into the process, the first step is the modeling approach. The primary objective, as I mentioned, for this entire presentation is walking you through the machine learning model development, model building, model optimization, and interpreting of the model. So for this particular um, model, we are predicting a continuous numerical value. That's why this is a regression problem. As you can see on the slide, various features are temperature, ambient pressure, relative humidity, and exhaust vacuum. As this is a regression model, I'm going to use a number of regression algorithms such as multiple regression, as we have multiple input variables or features and one dependent variable. When I was doing a quick glance of a data and just doing some basic Excel charts, I felt that the relationship between the independent variable and the dependent variable may not be linear. So I may use like non-parametric algorithms such as uh, random forest regression, maybe just to evaluate if there is any non-linear relationship. Just to conclude, in context of our combined cycle power plant, as we have multiple independent variable and one dependent variable which is continuous numerical value, I'm just going to start my modeling approach with multiple linear regression as a baseline. Moving on quickly, how I build my model. So for model building, I use a couple of steps such as preparation of my data, doing some basic as well as some thorough data analysis, model selection, then train my models. Then I did the evaluation and then did optimization. Just want to quickly touch base that I use Excel, I use Python as well as Google's AutoML as my primary tools for creating my models. As you can see on the right hand side of the slide, when I was doing my data analysis, I used descriptive analysis, descriptive statistics, as well as some charts such as line plots, scatter plots, etc. And as you can see on the right hand side, the top figure, where you can see I have plotted a scatter plot between the predicted and actual values, and which you can see the plot is curved, kind of um, confirming my doubt that I may not be dealing with purely linear relationship between the dependent and independent variable. I will kind of explain this in detail as we move forward. Moving on to the model selection, again, as I already covered, that I use the multiple regression model, and just want to quickly also talk about the random regression model. As you could see on the right hand side bottom figure, this particular ensemble model uses decision trees that can capture non-linear relationship and interactions between features. Moving on to the model optimization. So for my multiple linear regression model, I did not use any hyperparameter tuning, but for my excuse me, random forest regression, I try to tune hyperparameters such as number of trees and then the depth of the tree using grid search CV, and the cross validation using k-fold um, cross validation technique, where I divided my data into 5 different folds and then tested using those folds to tune my model. When I evaluated these various models, what I found out that the random forest regression model is generally better over multiple regression model. You could see, various metric I use like R square, mean absolute error, mean absolute percentage error. And what I found out that the random forest regression model perform way better than multiple regression model. And I'll actually kind of explain my model evaluation in this slide. As you can see, I have both the models and their various metrics comparison posted here on the left hand side, and you can see that the random forest almost in all metrics perform better compared to multiple regression. So like what I will conclude that random forest model fits this particular data very well, because I have like quite high my R square value, almost 96, like 0.962, kind of mentioning that almost 96.2% of variance is explained for target variable using random forest. And then while I just want to also mention that while random forest may capture the trains, the numerical predictions are inaccurate. The model usefulness really depends here on the tolerance of error, and I think it requires further analysis of PE data. So what I would like to conclude is that this model definitely performs significantly better on the log of the target variable than raw data itself. Thank you for listening to my assignment. Have a nice day.